Hello, this is a demonstration of my Raspberry Pi. I am Christina and this is for my workstation and server project class. I did a Raspberry Pi proximity sensor. So I have a quick slideshow. I'll show the object of my project was to write a program that will warn someone if an object is too close. You've probably seen this in vehicles and whatnot. The uses are many: home security, vehicle security, child gate, pet gate, garden fence, construction. All kinds of applications can be used for this. And how it works with a server, since this was for a server class, is that the code can be put on a server and retrieved for use, and also recorded data can be placed on a server for retrieval to audit events. There's a couple different things that we need for this. I used a Raspberry Pi 3 Model B+, a 2.5A power supply, a 32 gigabyte SD card, HC SR04 ultrasonic sensor, a breadboard with 400 points, a Model BB808, a 330 ohm resistor and a 470 ohm resistor, and then also the I spelled USB keyboard wrong, USB mouse, and an HDMI monitor. First off, we formatted an SD card with FAT32. They added the Noobs 2.70 or later to the SD card. Because of the model, we needed a 2.70 or later. I put the formatted SD card into the Pi, connect the hardware, connect the sensor to the breadboard, connect the breadboard to the Raspberry Pi, write the code, and run the program. I do have documentation on how to do this. I'll see if I can link it to the video. So the proximity sensor, it's, like I said, it's an HC SR04 ultrasonic sensor with a 5 volt direct current power supply, and it has a ranging distance of 2 centimeters to 500 centimeters, which is actually pretty significant. It sends out a 40 kilohertz frequency to detect whether there is a pulse signal back, kind of like a bat with echolocation. There's 4 pins: the VCC, the trig, the echo, and the ground. There's more documentation on how to connect the breadboard with the Raspberry Pi in a more developed environment. This would be direct circuitry, there wouldn't be a breadboard. And the code, I will show you the code in a little bit, but what it does is, well, first off, I used Python. I've never used Python before. This is my first time writing Python code. This is the first time I've really used Linux outside of a development environment. And it's the first time I've ever used a Raspberry Pi or circuitry of any of that sort. So this was really fun for me. So what the Python code does is it measures the time from the time the signal is sent out to the time it was received, and it multiplies that by the speed of sound, which is, as you can see on the screen, 34,300 centimeters per second. It divides that number by 2, and then you get your distance. And for this project, I use 6 centimeters because I'm doing this on my desk as the range that we're going to use. So if the object is closer than 6 centimeters away from the sensor, the background will display red with green lettering and warrants of an impact and distance. Otherwise, or else, it displays a black background and distance of being recorded in the regular cyan blue that you'll see. So this is the setup. As you can see on that right there, my sensor is over there, the breadboard, and the Pi. And this was the citation. I used this tutorial quite a bit in setting things up, but there was some code that I ended up changing because this didn't have everything I needed. It just gave you how to get the Pi going, but I did add the warning system for the screen and whatnot. That was something I did on my own. So now I'm going to get on with the demonstration here. So back up here, I've got my Pi set up over here, it'll be displaying on the screen here. This is my setup right here. This is my Raspberry Pi, the breadboard, the sensor. I've got it set up backwards from what the other screenshot was. And when I put my hand in front of it, it'll measure the distance. So we'll get started. First off, I will show you the code. Give me a second here. I've got a bunch of different screens going. So I'm going to show you the code first. Whoops. So this is the code. Sorry, it's a little shaky here. I've got the different libraries installed here. The RPI, GPIO stuff, that's setting up the pins that are connected to the Pi. As you can, it's not a good picture. Right there are the pins. That tells it where it is. It maps it out for the program. And then I also have a time library and color libraries so that I can demonstrate an impact warning. Let's scroll here. Sorry again for being shaky. So this is my distance method. It sets up the different triggers and stuff that have to be done. That was all part of the tutorial that I showed you. The link to the tutorial, that was all in there. This part was all part of it too, except right here. This is what I added. While true, distance equals distance. So we're calling the distance from up further. If the distance is less than 6, print impact warning, print for green, black, red, distance, and it'll print out the distance. Otherwise, it's going to just black background with the letters are going to be cyan, and it's going to print the distance. So that was something that I did on my own that wasn't part of the tutorial. So we will close out of that, and I will show you the running script and do a demonstration here. Sorry about that. Okay, and now I'm going to run the script. I've got one hand and 2 keyboards, so bear with me. Whoops, nope, that's not what I need. Sorry about that. Bear with me. And that's my script, or my command for running it. Oh, Python command not found. Oh. Okay, helps if you spell things correctly. So as you can see right now, it's measuring. You see all that. This is my sensor. Measured distance 4.2. It's, and now I'm moving my hand away. So there we go. A working proximity sensor, and like I said, this has many different applications, and this was a lot of fun for me. Thank you.